Number 2 on our supplemental wave problem reads as follows. If you sleep in the back of class 4 meters away from the teacher, you're smart, you're hiding from me, okay? And the teacher yells at you at a frequency of 530 hertz. La! How many wavelengths will there be between you before you hear the noise and wake up, okay? And so we'll see what we get. Hopefully we'll get around 6.24 there, okay? So the first thing we want to do is make a what? Make a picture. That's correct, okay? And the point of making a picture isn't to waste your time, but it's to help you visualize what's going on here, okay? So let's take a look at wave problem number 2 here. Step 1, we make a little sketch. Here's Mr. Lau yanking at the front of the board here. La 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 la. Here's you at your desk, and you are sound asleep, okay? So then I yell at you, la, okay, and I send out a sound wave, la, to wake you up there. And that's the basic idea, okay? In this case, the picture is actually kind of helpful because we learned some facts about the classroom, okay? What do we know about the distance between you and me? We are 4 meters apart, okay? So half the problem is just kind of trying to know what the problem is about there. Okay, so conceivably, if you know how many wavelengths are between my yelp and you can invent a device that generates the exact opposite sound wave of the same size and frequency, but 180 degrees out of phase. So cancel out my yelp, and then you wouldn't hear me. You could just keep sleeping, okay? Next, step 2, list all of the what? Knowns and unknowns, right? This distance is 4 meters, okay? Between the source of the sound and you, okay? What else is given? Frequency, thank you, is how much? 530 units. Hertz, okay? Always put on the units because that way you make sure that you're in consistent metric units. You don't have to convert. And also, it clues you into what it really is. If it's hertz, it's frequency, right? If it's meters, it's distance or wavelength. If it's seconds, it's the time or period, right? And what's left? It asks you for what's the number of wavelengths between you and the teacher, okay? So that's not a normal thing we're trying to solve for, but this is a clue. What are we really trying to solve for? We're trying to solve for the wavelength, right? Aren't we trying to find the wavelength in meters? Okay? So here's what's tricky about this problem. There's a piece of hidden information. You have to assume that you live on which planet? Earth. Welcome. We come in peace. What do you know about Earth? Earth is, yes, surrounded by air, and the velocity of sound in air is 340 meters per second, okay? You can assume that for all those problems, unless it's stated otherwise, okay? In fact, it says it at the top of the sheet there, okay? So in other words, not every problem is going to be like, we live on Earth, yay, Earth has air, yay, sound travels in air at 340 meters per second. It's hidden information. Got it? Next, step 3. How do you know which equation to pick? Real easy. Just pick the one that relates the knowns to unknowns. I want to know wavelength. I know velocity is 340. I know frequency is 530. We can use equation. Yep, V equals lambda F, okay? Velocity is equal to wavelength times frequency. It's the Greek letter lambda. We're trying to get used to new symbols. So that's probably part of the vocab learning curve right there, okay? Instead of si habla español, parlez-vous français, guten tag, konnichiwa, whatever, we're speaking some physics here, okay? So now, step 4, we can just shove in all the numbers from step 2. What do we put in for V? 340. What do we put in for lambda? Lambda. What do we put in for F? 530, okay? And you're saying, well, shouldn't we rearrange the equation and all that? I actually prefer you don't, because I find that when people rearrange the equation, they make up their own equation. Or they're like, oh my gosh, there's 500 equations. There's really just a basic set of 3 we're working off right now. So keep it simple, okay? So now it's piece of cake. How do you solve for lambda all by itself? Divide both sides by what? 530. Get out your calculators, plug and chug, okay? You do yours, I'll do mine. You'll probably beat me because mine has to boot up, okay? So I just do 340 over 530. Oh, this is slow. What do you guys get? Okay, yeah, we'll just go with what you have. 0.64 units. 0.64, what are the units? 0.64 meters, okay? But we're not done because we want to know the number of wavelengths between you and the teacher, okay? So here's what I call just using common sense. Don't worry about coming up with another equation, because I had some people in class trying to derive their own equation. Let's make it complicated. If there's 4 meters between you and me, and one wavelength is 0.64 meters, how can I figure out how many wavelengths would fit between you and me? I just take 4 meters and divide it by 0.64, okay? So the number of wavelengths is what we're trying to get. The number of lambdas will just be 4 over 0.64. Okay? And when you do that, what do you get? 4 over 0.64. Yeah, it's like about 6 1/4 or 6.24, whatever, okay? I'm not really worried about 6.24 lambdas or wavelengths, okay? So about 6 wavelengths between you and me, okay? Something like that. So in real life, when would you ever do that? Probably never, right? Okay? But if you're designing like an auditorium or an acoustical chamber, usually you need to know the sound properties of a room, and the number of wavelengths would affect how they would reflect off walls, if they would cancel out, if you get dead spots, and what's called destructive interference there, right? So if you notice, if you ever watch like a making of a video or a music video or a recording, you see like the recording studios with all the padding on the walls to record sound. Or in the auditorium, it's awesome. The acoustics are awesome. You stand on stage. If someone whispers, you can hear it all the way back. And I don't know if you ever noticed during assemblies and stuff, but there's like these little slits on the side of the auditorium. And I thought it was like for heating vents and all that, but I looked in there. There's like nothing in there. So I think it's something to do with the acoustics. And I don't know, do you guys use it for storage or something down there? There's like these little slits on the side of the walls in the auditorium. So next time you're in there, just take a look, okay? All right, pay attention to the assembly. Oh, there you go. Okay, so in a nutshell, that's number 2. So notice 4 steps is designed to help you break it down. Your teacher's yelling at you, wake up, slagger, blah, woo. Okay, frequency, 530, distance, 4 meters, break it all down. And now my calculator booted up. There you go. Okay, that's number 2.